Friends, in part 2a of straight line, I have discussed 5 forms of equation of straight line. In this part, I will discuss the remaining forms of equation of straight line. So let us start the next form, sixth form, distance form or parametric form. In this form, equation of straight line is expressed in terms of a parameter. Parameters are those variables which are used in place of x and y. In this case, the distance r and theta will be taken as parameter. So let us first draw a straight line. Which makes an angle theta with x-axis, and this line passes through a point having the coordinates x1, y1. Now let us consider one more point here, Q, at a distance r from P having the coordinates x, y. Now the equation of the line will be represented in the form of x, x1, xy, x1, y1, r and theta, distance r and angle theta. For deriving the equation of line, let us draw perpendicular from the point Q on x-axis QM, and another perpendicular from P, which is PN. QM and PN are perpendicular to OX. PM, QN are perpendicular to OX. Now from the point P, draw another perpendicular on QM, which is PR. Draw another perpendicular PR on QM. Now, since PR is parallel to x-axis, therefore this angle is theta. Angle QPR is equal to angle QAM is equal to theta. Corresponding angles. Now let us consider this triangle PRQ, and this point P has the coordinates x1, y1. So this distance is x1 and this distance Pn is y1. From the point O, the point Q has the coordinates x, y. So the horizontal distance OM is the x coordinate of point Q, and QM is y. Now this PRMN is a rectangle, so this distance is also y1. Now QR, distance QR, it will be equal to QM minus RM equal to y minus y1. Now this PRMN is a rectangle, so this PR, distance PR will be equal to MN. PR is equal to MN, and MN is equal to OM minus ON, which is equal to OM is x and ON is x1. So x minus x1. So now in this triangle we have got the side QR and PR. So in right triangle PRQ, we have got the two values, that is PR is equal to, PR we have calculated here, x minus x1, and QR is equal to y minus y1. Now this Q point is at a distance r from P, that is PQ is equal to R. Now we will express x and y in terms of r and theta. If x and y are expressed in terms of a third variable, in terms of other variables, then this type of form is known as parametric form. So now let us consider in right triangle PRQ. If we take cos theta is equal to PR, base upon hypotenuse. Cos theta is equal to PR upon PQ, which is equal to PR we have calculated x minus x1 upon PQ is equal to R. In the same triangle, if we consider sin theta is perpendicular upon hypotenuse, sin theta is equal to QR upon PQ, and QR is, we have calculated y minus y1, y minus y1 upon PQ. PQ is the distance R. Now we can write x minus x1 is equal to r cos theta, comma y minus y1 is equal to r sin theta, or we can say x minus x1 upon cos theta is equal to y minus y1 upon sin theta, and both these values are equal to r. From the first we can calculate r is equal to x minus x1 upon cos theta, and from the second r is equal to y minus y1 upon sin theta. This form of the equation of straight line is known as parametric form. Here x and y have been expressed in terms of the distance r and theta. These are known as the parameters, this distance r and theta. Now Q point has the x coordinate, so Q point has the x coordinate equal to, from this relation we can find x is equal to x1 plus r cos theta, and y coordinate of point Q is equal to y1 plus r sin theta. So this form is known as parametric form. Now if we take a point Q dash on the opposite side of T, that is in the direction PQ dash at a distance r, then that point will have the x coordinate is equal to x1 minus r cos theta, and y coordinate will be equal to y1 minus r sin theta. Or you can write this equation in this form: x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to plus minus r, because these points are possible on both sides of the point P. So this form is known as parametric form of straight line. Students, the next form, seventh form of equation of straight line, equation of lines passing through a given point and making a given angle with a line. Let us draw the lines. X-axis, X dash, Y, Y dash. There is a line having the equation y is equal to mx plus c. Now let us draw two lines passing through the point x1 comma y1. And these lines make angle alpha with the line y is equal to mx plus c. We want to find the equation of these two lines. Let this lines be L1 and this line be L2. The first line is making angle alpha in the anti-clockwise sense, and the second line is making alpha in the clockwise sense. So first, if we want to find the equation of these two lines, we should know their slopes. Let this angle be theta 1 here and this angle be theta 2. If we find the slope, then we are having this point x1 comma y1 through which these two lines pass. The first line with which these two lines make equal angles make angle theta with x-axis, and these lines are making theta 1 and theta 2 angles. Now if this angle is alpha, then this angle is vertically opposite angle, so this is also alpha. Let us name these points as A, B and C. Now in this triangle ABC, in triangle ABC, this angle theta 1 is the exterior angle for this triangle. So theta 1 is equal to, exterior angle is equal to sum of interior opposite angles. So with the help of this angle, we can find the slope of the line L1. Slope of line L1. Slope of line L1 is, let the slope of this line be M1. M1 is equal to tan theta 1, which is equal to tan of theta 1. We have calculated theta plus alpha. So this is equal to tan theta plus tan alpha upon 1 minus tan theta into tan alpha. First line makes angle theta and its slope is m. So m is equal to tan theta. So we can write the slope of this line L1, slope of line L1 is equal to m1 is equal to tan of theta 1, and this is equal to tan theta. Tan theta is equal to the slope of this line, which is m. So m plus tan alpha upon 1 minus m tan alpha. This is the slope of the line L1. Now the equation of line L1 will be equal to, equation of L1 will be equal to y minus y1 is equal to, because this line is passing through the point x1 comma y1. So y minus y1 is equal to m1 into x minus x1. m1 we have calculated, which is equal to m plus tan alpha upon 1 minus m tan alpha. So putting the value here, we get the equation y minus y1 is equal to m plus tan alpha upon 1 minus m tan alpha into x minus x1. This is the equation of the first line, but there is one more line. Now let us find the equation of line L2. For finding the equation of line L2, we need the slope of line L2. It is making angle theta 2 with x axis. So now let us write theta in terms of angle alpha and theta. So let us consider the triangle in which theta 2 is the exterior angle. So let us name these points as D and E. Now in triangle ADE, this theta 2 is the exterior angle. So theta 2 will be equal to sum of the interior opposite angles. Here this angle is alpha and this is a straight line. So this angle will be pi minus alpha. Angle ADE is equal to pi minus alpha. Now in triangle ADE, angle DEX, that is theta 2. Theta 2 is equal to sum of the interior opposite angles, that is angle theta plus pi minus alpha. Or we can write this is equal to pi plus theta minus alpha. Now we will find the slope of this line L2. Slope of this line is M2 is equal to tan theta 2, tangent of the angle which it makes with the positive direction of x-axis. So this is equal to tan of pi plus theta minus alpha. And you know that tan 180 plus theta is equal to tan theta. So we can write this is equal to tan of pi minus tan of theta minus alpha. Now we have got the slope of this line, and this line is passing through the point x1 comma y1. So equation of line L2, equation of line L2 is equal to y minus y1 equal to m2 into x minus x1. Slope m2 is equal to tan of theta minus alpha, which is equal to tan of theta minus alpha into x minus x1. Now using the formula of tan of a plus b, tan a plus b is equal to tan a minus b is equal to tan a minus tan b, that is tan theta minus tan alpha upon 1 plus tan theta into tan alpha into x minus x1. So y minus y1 is equal to tan theta minus tan alpha upon 1 plus tan theta into tan alpha into x minus x1. Tan theta is the slope of the line y is equal to mx plus 3, that mx plus c, that is m is equal to tan theta. So we can write this is equal to m minus tan alpha upon 1 plus m tan alpha into x minus x1. So y minus y1 is equal to m minus tan alpha upon 1 plus m tan alpha into x minus x1 is the equation of line L2. We have already calculated the equation of line L1, which is y minus y1 is equal to m plus tan alpha upon 1 minus m tan alpha into x minus x1. Now we can write the combined equation of these two lines. So the combined equation will be then y minus y1 is equal to, for the first line, m plus minus tan alpha upon 1 minus plus m tan alpha into x minus x1. So this is the equation of the line, combined equation of the lines which make angle alpha with the line y is equal to mx plus c. M plus tan alpha upon 1 minus m tan alpha into x minus x1 is the equation for the line passing through the point x1 y1 and making angle alpha in the anti-clockwise sense with the y is equal to mx plus c. And the other one equation y minus y1 is equal to m minus tan alpha upon 1 plus m tan alpha into x minus x1 is the equation of the line L2 which passes through x1 y1 and makes angle alpha in the clockwise sense. So with this, this topic is complete. Like and subscribe my channel for new videos.